What skills do we need as mechanical engineers? Which ones should we be spending our limited time on? It can be easy to think, get this, and this skill, and you'll be golden. But it depends on what career path you're going into, and mechanical engineering is used differently in different industries. So with mechanical engineering, having a lot of graduates and being quite competitive at the entry level, let's discuss some of the best skills you can develop. Specifically, let's discuss the skills that are most versatile and widely needed by multiple industries with mechanical engineers. Before we talk about important skills for mechanical engineers, be sure to hit the like button and subscribe to this channel to hear more about how to supercharge your mechanical engineering career. So the first skill we'll talk about is geometric dimensioning and tolerancing. So this is where we discuss the ranges that can be assigned on dimensions for what the error of the dimension is, and we show these on drawings to show how far off they could be from the assigned dimension. So in this example, we have a drawing of a flywheel for a car, or a flywheel for some kind of rotating equipment, and the assigned size is 0.5 inch diameter, but it assigns a tolerance of plus 0.001 or minus 0. So what this means is that the hole could range from a size of 0.5 to 0.501. And then some of this terminology here is referring to maximum material condition, which is what this M stands for, meaning if the hole was as small as it could possibly be, that would be the maximum material condition in this case. With respect to surfaces, or in this case, they call them datums A, datum B, and then there's a datum C somewhere else on this drawing as well. So that's kind of what GD&T is it's assigning tolerances, aka allowable variation, onto dimensions of crucial parts of whatever you're designing in order to make sure that it properly still meets its fit, form, and function. And so any type of mechanical design position would very likely utilize this because it's crucial. If these holes were too small, the fastener wouldn't fit through it. And if they were too big, this entire part would be rattling around way too much and stuff. So it's crucial to make sure that these really important dimensions are as in line as they can possibly be. But also, if these dimensions were way too tight, if the tolerances were way too strict, then the part would be more expensive. So from a business standpoint, they do strike a bit of a balance between what could we really realistically allow, but it doesn't necessarily have to be perfect, because perfect would be too expensive. So there are definitely courses on this out there. I do remember taking one called GD&T Basics, which costed money, or there's probably also free resources on YouTube or elsewhere, but if you intend to go into a mechanical design position, I strongly recommend this. The second skill we'll talk about is project management, and this is not as technical, but for aerospace or construction or other types of technical projects, they definitely value someone who can speak the language, speak the technical language and engineering language to engineers and also to upper management to understand what's going on in the project, what various constraints or problems it might end up happening. And so that's where, if you know how to have good leadership skills and good interpersonal skills with a variety of different departments, and also keep track of the project well, then this is going to be very useful. And not to mention, not only is this very useful in engineering, but it's very useful in so many other different industries. And in the construction industry, that's always been super hot. There's always tons of construction going around, and you probably will have a pretty easy time getting a job if you're an experienced project manager. So yeah, it's very flexible, needed in a wide variety of industries. I guess even if you're not necessarily doing a strict project management role, like there might still be some project management aspects to certain types of roles, or especially if you're a more senior level design or analysis engineer, you might be doing more of keeping track of what's going on in certain projects and stuff or certain tasks. So this could be useful for that as well, even if you're not using the same degree of project management types of skills. Now, I will say I could see people sometimes being frustrated with this one because you do deal with a lot of BS that people might have and stuff, and there's conflicts between teams, or why aren't things getting done, and then pressure from management about why that's going on. Like, one of the project managers on one of my current tasks is dealing with a lot with just so many problems on the project and stuff, and having to deal with upper management. So there's stuff to consider. Be sure to understand what you're getting yourself into, but I do think the reward is great in just the versatility of your career and everything you could possibly do with it. The third skill we'll talk about is structural analysis, which, again, the construction industry, which is super hot, and that's definitely going to be in high demand. And you could use finite element analysis, which is effectively where you break up a structure into pieces and the software is going to analyze each piece for you. You apply loads and constraints on the entire structure, and then the computer will actually solve it for you. Or in some cases, things that are simple might call for more hand calc type of stuff. Although that's more rare nowadays, but like the Golden Gate Bridge, for instance, I have seen in videos or heard about just pages and pages of structural calculations they did for it and such. And on this type of thing, looks like some kinds of strut structures to some extent. But this is really important because you're the one making sure that a building or an aircraft or something critical is going to be safe, especially if there's going to be people in it. It's a little bit of a different story if it's like a satellite that's unmanned or an aircraft that's unmanned. Even in that case, a failure would be super expensive. But especially when it's people in it, like, that's way higher stakes than just simply an expensive failure. So they're going to take this kind of thing seriously, especially for things like buildings or bridges and aircraft and stuff like that. So this is definitely a skill that a lot of engineers also just find it interesting. You're required to use your brain, and time goes fast and everything. So definitely a good skill to be learning. And then another one is computer-aided design, which I think pretty much anyone interested in engineering understands at least the basics of what this is. You're looking at a screen on a computer where you're modeling the 3D version of a part on the screen. So like a bracket like this, the 3D version of it. And you also do 2D drawing versions of it as well, like what we showed in this example. But you add the GD&T onto the 2D drawing. But yeah, for computer-aided design, it lets you model out on this dimension what the parts look like and on this plane, and then extrude things to get this 3D bracket. It also lets you assemble everything together to see how it assembles and see if there's interferences and such. And some tools, especially like SolidWorks, let you see the motion analysis, or in some case even like collisions and stuff. But so this is definitely important for fit, form, and function. And it's part of what people might call digitizing, or the more modern version of how back in the day they would actually use all kinds of drawings, and it would take way longer. They would have to compare all kinds of like hundreds of drawings with every part to each other to make sure there's no interferences and such. And nowadays you can see it more in a 3D interactive screen. So definitely a good skill, and it's also one of those interesting ones that people sort of equate to being a hobby. And the last one we'll talk about, and admittedly this is the more boring one, but knowledge of specifications that are relevant to the job that you're trying to do. And the example that I'm showing here is FAA Part 23 for aircraft. And the industries and the governing bodies know what kinds of failures there could be and how to prevent them. So understanding these types of specifications and how they can be applied in various industries is going to be super important. And you'll definitely impress employers by having some degree of understanding of them. And in this case, talking about how structures could work well for aircraft, or especially aircraft that are going to be carrying people and such. And we see governing for airspeeds and descent speeds, and so that would govern what kinds of loads go through the aircraft. And a similar thing when it's like construction sites or buildings. You're going to have different governing bodies having specifications about sizes of pillars, where pillars need to be in buildings to make sure that they're not going to collapse, that there's not going to be dangers of being inside them. So yeah, these are definitely there for a reason. And if you have a certain industry in mind that you intend to work in, strongly recommend understanding what some of the relevant specifications are, and use, especially if you use AI or other tools, just to dabble around in it and get a basic understanding. Like, that's going to go a long way. So yeah, those are the top 5 skills I would recommend to supercharge your engineering degree. If you found this video helpful, please give it a thumbs up and subscribe to this channel, and provide any comments you may have or questions you may have about any of these skills and how to obtain them. I look forward to talking to you next time. Peace out.